x minus 3 is a factor of f of x. In other words, if you divide f of x by x minus 3, you will get remainder 0. I mean, what's the quotient? That's what we're after. So we can use synthetic division since we have x minus a number. So remember, we have this little grid here. We have the coefficients of our dividend, our polynomial. As you can see, we have 1, 8, minus 5, minus 84. X minus the number 3 in this case is the first one here. And what do? This 1 we bring down. Then, what do? We multiply 3 times 1, which is 3, right? That's why the 3 goes here. And you can see on the next slide, because again, I did send the notes, 8 plus 3, we get 11, right? We multiply, we add, and here we're going to have 11, as up here. Then we repeat the process essentially. We have 3 times 11 down here. That's 33, which goes up here. 33 is here. We add, we get 28. So 28 is what's here. Next would be 3 times 28. Right? 3 times 28, which is 84. Then negative 84 plus 84, you get 0 down here. And that's what we got, 0. Remember, the last number here, the number here in the last column, that's always the remainder. So the remainder here is 0, which is what we expected. These numbers are the coefficients of our quotient. And the quotient is always 1 degree less than the dividend. Our dividend is our polynomial, right, here. X minus 3 is actually the divisor. This is degree 3. So the quotient is degree 2. So the quotient is going to be x squared plus 11x plus 28. And the remainder is 0. So using the division algorithm, remember how you can write the dividend as the divisor times the quotient plus remainder? Remainder is 0, so this is what we get. But now we want to factor this thing. Although that's not bad because this is degree 2, its leading coefficient is 1, as we can see. So here we want to factor this. And it's a trinomial as well. 2 numbers then whose product is 28, but the sum is 11. Fill in these blanks, so to say. Well, from the notes you could see, although even without the notes you should be able to see 4 and 7 are going to pull it off. Right? 4. Yeah, let me write those numbers in. We have 4, 7, right? Their product is 28, and their sum is 11. Okay. So we get x plus 4 times x plus 7. And now we put it in, multiply it by x minus 3. That's our factorization. All right. Any questions on this? Next one's a little bit different. The next one we actually use long division. Now this one's going to be a little bit different. Hopefully I'll finish it. I'll be able to finish it, I mean. Here we have this polynomial, which is f of x, right? As you can see. We're going to divide it by x squared plus 4. Now, For this one here, okay, we have to fill it, we need zeros for missing terms, right? There's no x to the fourth term here. So we're going to use 0x to the 4, right, as our placeholder. Notice there's no x squared here. 0x squared we need also in the dividend. And then we have minus 6x plus 9, we're good. For the divisor, we're missing an x term, so we put 0 times x. And just like with long division of numbers, you know, we set it up this way. And again, we divide leading coefficients. We have x to the 5th divided by x squared. Well, that we know is x cubed, right? And so we get x cubed. What we do next is we put this over its like term in the dividend. So we have x cubed, we have 8x cubed here, that's its like term, so we put it over, we put x cubed over it. Then, with just like division of long division of numbers, we have to multiply and subtract. So we multiply here, we have x cubed times x squared is x to the 5th. X cubed times 0x is 0x to the 4th. I mean, really it's 0, but just to keep everything consistent, I'm writing 0x to the 4th, and x cubed times 4 is 4x cubed. Now we're subtracting, right? So we want to distribute the minus sign here. And that's what I'm doing here. Now, when we do that, we combine. These terms go away, right? You know, x to the 5th minus x to the 5th is gone. 0. Excuse me, it's 0. 0x to the 4th minus 0x to the 4th. That's just still 0. Here we get 4x cubed. And we bring down the next term, as you can see. Now for 0x squared, okay, so we bring that down. So now we repeat the process, but we repeat the process because the degree of the difference, right, is bigger than or equal to the degree of the divisor. So this is degree 3, this is degree 2, so we have to repeat the process. So we do 4x cubed over x squared. That gives us 4x. The 4x we put over the like term, which in this case is minus 6x. I use 0x squared as a placeholder. Okay, that's what I did. And now we did this, but now what do? We multiply and subtract. We have to multiply 4x times this, right? And then we subtract. So we subtract 4x times this and subtract that. That's how we get 4x cubed plus 0x squared, right? 4x times x squared, that's 4x cubed. 4x times 0x is 0x squared. 4x times 4 is 16x. Okay, I know I'm going a little quick, but again, we're getting close to the end. We subtract, right? Here, what we do is we distribute that minus sign, as you can see. We subtract, right? And we end up with minus 16x. The rest, we actually do have to stop here, but the rest of the terms you bring down and combine. That's what I'm saying here. I'll have to go more into that next time. So this example we will finish next time. We're on this slide. It's just that we're out of time now. So let me stop sharing this.